All right, so d equals vi times t plus 1/2 of at squared. So d is going to equal vi, which is 0, times 4 plus 1/2 of negative 9.81 times 4 squared. So this cancels, so you're left with d equaling 1/2 of negative 9.81 is a negative 4.9 times 16. And negative 4.9 times 16 is going to be a negative 78.4 meters. You can answer it that way, or 78.4 meters down. Okay, either one of those answers is correct. It's actually easier when you have a displacement question. When you're dealing with displacement, it's actually easier when it's negative because the negative's already there. You don't have to add, you don't have to remember to add, quote unquote, a positive sign or whatever sign it is. Hi.
I didn't know what you're doing. I just had a question, but I can come back if it's easier. I just wanted to know what my grades were because I can't get.
You have to come back.
Okay.
All right.
Is Mr. Mateo here?
He is. So I mean, he might be able to do it for you.
Okay.
All right.
Yeah.
All right. So that's number 12. Number 13. A motorcycle is traveling 20 meters per second and it accelerates at negative 5 meters per second squared. How long will it take to come to a complete stop? So a motorcycle traveling at 20 meters per second, okay? (20 meters per second), okay? Okay, we don't know what the final velocity is, okay? But we do know that it's moving this way, but acceleration is moving in a negative direction. It's working against it because it's slowing it down. But the displacement is still going this way, so it's still going to be positive, okay? So how long will it take to come to a complete stop? So we know that the initial velocity is 20 meters per second. We know that the final velocity, because it's coming to a complete stop, is going to be 0 meters per second. All right, so now we can make our chart to determine the time it takes for it to stop, right? Time, yeah, how long? So VI, VF, A, T, D. Oh, God, that's terrible. All right, so 20 meters per second, 0 meters per second. Acceleration is negative 5 meters per second squared, okay? How long will it take to come to a complete stop is what you're solving for. Time, you don't have displacement, and that's fine. You don't need displacement to be able to do that. All right, so let's look at what we want to use. What equation do we want to use? So what equation do we want to use? We don't have displacement. We do have final velocity, initial velocity, and acceleration, and we can solve for time. So we're going to use the first equation. VF equals VI plus A times T. Okay, your final velocity is 0. Initial velocity is 20. And it's going to be a negative 5 times T. Okay, now to get T by itself, you got to subtract 20 from both sides. So it's negative 20 equals negative 5T. Divide by negative 5, that cancels. And you're left with T equaling 4 seconds. Now you'll notice I've done these. I'm not putting the units in the math. I just know what they need to come out to because I've been doing it over and over and over again. So that's what I'm doing. I will say to you, I don't have a problem with you guys doing that, but you have to put the units everywhere else. You have to show them on your diagram, you have to show them on your chart, and you have to show it in your final answer. Okay? All right, so that's number 13. Number 14. 14 is a car accelerates from rest at 3 meters per second squared for 8 seconds. How far does it travel? Okay, so car is at rest, 0 meters per second. It accelerates in a positive direction. The displacement would also be positive. Okay, and and it's going this way. Okay. We don't know what the final velocity is, which is fine. We don't need to. How far does it travel? So we need the time, which is 8 seconds. What is the acceleration? It's 3 meters per second squared. Okay, and now we can make our chart. So VI, VF, A, T, D. Okay, your initial velocity is 0. Your final velocity you don't have and you don't need. 3 meters per second squared for acceleration. And your time is 8 seconds. And what are you solving for? You're solving for how far it travels. What's its displacement? Okay, so we don't have final velocity. You're not given final velocity. You're solving for displacement, so you're going to use the second equation. D equals VI times T plus 1/2 of A T squared. All right, D equals 0 times 8 plus 1/2 of 3 times 8 squared. So this is going to be D equals, this cancels because it's 0. 1/2 of 3 is 1.5 times 64. Okay, and your displacement is going to be, when you multiply this out, positive 96 meters, or 96 meters to the right. Either one of those would be correct. If this plus sign was not there, then it would not be correct. All right, so that's number 14. Let's go back to 15. Okay, so 15. I know 15 could be a little bit confusing because it says down a slope. Don't necessarily worry about that kind of question yet. Just think of this as horizontal. So just think of it that way. So I'm going to draw it like this. And starts from rest, so 0 meters per second. And then dude comes this way. God, I hate drawing. And accelerates down the slope at 4 meters per second. So the acceleration is positive, 4 meters per second squared. Time is 6 seconds, and the displacement's going to be positive as well. All right. How far does the skier travel? So let's make our, we don't know what this is. We don't know our final velocity. All right. VI, VF, acceleration, time, and displacement. All right, so our initial velocity is 0. Final velocity we don't have and don't need. Acceleration is 4 meters per second squared. Your time is 6 seconds. Your displacement is what you're solving for. All right, so again, you're going to use the D equals 1/2. Nope. Well, it really is. It's VI times T plus 1/2 AT squared. Because in this case, your initial velocity is 0 anyway. So 0 times 6 plus 1/2 of 6 times, nope, 1/2 of 4. Sorry, 1/2 of 4. Let's do this the right way. 1/2 of 4 times 6 squared. So this is going to be D equaling, this cancels. 1/2 of 4 is 2. 2 times 36. Displacement is going to be a positive 72 meters. Or, and in this case, if you said this, I would accept this. Okay, positive 72 meters or 72 meters down the slope. I would accept either one of those answers, especially for this type of question. But this, I shouldn't have put this question in there because this deals with kind of up, kind of left, right, and up, down, which we'll do two-dimensional motion later. So don't let that confuse you. Okay, let's go to 16. 16 is the cyclist accelerates from rest at 2 meters per second and travels for 60 meters. How long does it take? So now we're solving for time, okay? Zero meters per second. Moving this way. We don't know what this is. So we don't know what the final velocity is. How long does it take is what we're trying to figure out. The acceleration is going to be positive, and it's 2 meters per second squared. Okay, your displacement's also going to be positive. All right. And you're solving for time. All right, so do your chart. VI, VF, A, T, D. So your initial velocity is 0. Final velocity you don't have. Acceleration is 2 meters per second squared. Time is what you're solving for. And your displacement, in this case, was 60 meters. So it's a positive 60 meters. Okay. So you have displacement, you have acceleration, and you have initial velocity. So in this case, what are you going to use? You don't have final velocity. You're not given final velocity. So, but you do have displacement. You do have initial velocity, and you do have acceleration. So in this case, what could you do? You're going to use the second equation again. D equals VI times T plus 1/2 of AT squared. Okay, D is 60 meters equals 0 times T plus 1/2 of 2 times T squared. So really what you're left with is this cancels 60 meters. What's 1/2 of 2? 1, right? So you're just left with T squared. How do you get T by itself? You take the square root of both, and it's 7.75 seconds for your time. Make sure if you guys have questions, make sure you're pausing the video, writing down what your question is, and then either DMing me or getting it to me or coming to see me, whatever you need to do. Okay. All right. So number 17, let's do 17. So 17 is a vehicle decelerates from 100 meters per second to 20 meters per second over 160 meters. What is its acceleration? All right, so it's a car is going 100 meters per second. Still traveling in the positive direction. It's just slowing down. Okay, to 20 meters per second. Okay, acceleration is this way. It's going to be negative because why? Because it's slowing down. Your displacement is still going to be positive because it's still moving in the positive direction, and it's 160 meters. Okay, we don't have time, and we need to solve for acceleration. That's what we're solving for. Okay. All right. So VI, VF, acceleration, time, and displacement. So what's your initial velocity? It's 100 meters per second. 20 meters per second for final velocity. Your acceleration is what you're solving for. You don't have time, and your displacement is a positive 160 meters. Okay, so let's go back to our equations again. What don't you have? When you are not given time, the equation you should use is VF squared, VI squared times 2AD. Well, we have VI, we have VF, we have D, and we need to solve for A. All right, so this is VF squared equals VI squared plus 2 times A times D. VF squared is 20 squared equals 100 squared plus 2 times 160 times A. Okay, so this is 400. This is, oh my God, 1,000. I was like, what is this? Plus 320A. Subtract 1,000 from both sides. This cancels. Okay, and now you're left with negative 600 equals 320A. Divide both sides by a positive 320. And what you come up with is your acceleration equals this should be 10,000. Sorry, oopsies. Should be 10,000. So this should be minus 9,600. My bad. I know I was looking at 100 times 100 is not 1,000. That's whatever. All right. So 9,600 divided by 320, and it's a negative 9,600. The acceleration is a negative 30 meters per second squared, which makes sense. Why? Because your acceleration has to be negative. So because you're going from 100 meters per second to 20 meters per second, you're moving, velocity is positive, but your acceleration has to be negative because you're slowing down. Okay? Your acceleration will always be against something if the object is slowing down. All right, so that's 17. 18. Let's do 18. 18 is a swimmer. Swimmer goes from 1 meter per second to 3 meters per second in 2 seconds. Find the acceleration and the distance traveled. All right, so here's your swimmer. 1 meters per second, moving in a positive direction to 3 meters per second. You need to solve for acceleration. The acceleration is going to be positive, as is the displacement going to be positive, okay? And your time is 2 seconds, okay? All right, so draw your chart. VI, VF, A, T, D. So your initial velocity is 1 meter per second, 3 meters per second. Acceleration is what you're solving for. Time is 2 seconds, and displacement is what you're solving for. So first things first, what you can do, and what I did was I solved for acceleration first. VF equals VI plus A times T. Okay, VF is 3 equals 1 plus 2A. Subtract 1 from both sides. You end up with 2 equals 2A. Divide both sides by 2. And acceleration equals 1 meter per second squared. So that's the first one. Okay. You also have to find what the displacement is. So displacement, what I would use, the equation I'm using is D equals VI times T plus 1/2 of AT squared. Okay. D equals 1 times 2 plus 1/2 of 1 times T squared. D is going to equal, oh, T squared is 2, sorry. D is going to equal 2. Well, what's 1/2 of 1 is a half. What's half of 4? It's 2. So what's the displacement that would be covered? The displacement that would be covered would be a positive 4 meters. positive 4 meters or 4 meters to the right. Okay. So that's 18. Number 19. All right, let's go here, erase. Number 19. 19 is a sled begins at 5 meters per second and accelerates at 1.5 meters per second squared for 4 seconds. What is the final velocity? All right, so you have your sled here. Oh, that's how I did it, actually. Makes more sense. And it's starting at 5 meters per second. Goes this way. And accelerates. We don't know what the final velocity is. In fact, that's what we're solving for. The acceleration is going to be positive, and it's a 1.5 meters per second squared. And displacement is also positive, but we don't need to know what that is. All right. We don't need to solve for it. We don't need it because we have 3 other variables. All right. VI, VF, A, T, D. So your time is 4 seconds. Your acceleration is 1.5 meters per second squared. Your final velocity is what you're solving for. You don't have your displacement, and your initial velocity is 5 meters per second. Okay, so solve. What are you solving for? You're solving for the final velocity. You don't have displacement. So what are you going to use? Easiest one, VF equals VI plus A times T. Okay, so VF equals 5 meters per second plus 1.5 times 4. So you end up with the final velocity is 5 meters per second plus 6 meters per second, and it's 11 meters per second. So that's number 19. And then finally, number 20. Number 20 is a horse goes from rest, okay, to 20 meters per second in 50 meters. Okay, so 0 meters per second, moving in a positive direction. Okay. The distance, the acceleration is positive. The distance is positive. In fact, it's 50 meters. And we don't have that, we're not given the time. Okay, and we know that the final velocity is 20 meters per second. So we have to find the acceleration. So no time given. All right. VI, VF, A, T, D, plus 50 meters. Time we don't have. Acceleration is what we're solving for. 20 meters per second for final velocity and 0 meters per second for initial velocity. So we're solving for acceleration. So we're going to use VF squared equals VI squared plus 2 times A times D. All right. So VF squared is 20 squared, which is 400, equals 0 squared, cancel. So it's 2 times A times D, so 100A. All right, divide both sides by 100, and your acceleration is 4 meters per second squared. So that's number 20. All right, hopefully these help you. You're going to have to do 21 to 30 tonight or today. So make sure that you get that done. It's going to be one of those things. Um, yeah, so it'll be 21 to 30 that you need to get done. And that's it. And like I said, if you have any questions, come find me. All right, thanks. Peace.